All right. So we got, let's see if we can reproduce this one. We got f of x, right? What do we write it in coordinate planes? Y equals f of x, all right? And let's write down below in it here. Z equals g of x. Is that good? All right. Let's copy it down. So I copied it over here in the corner. This is what we want to prove. F of x times g of x, slope of the tangent line at x equals a is this form, right? Good. So we look at y equals f of x and g equals z equals g of x, and what do we do next? I think we worked on delta y. You think? Anybody remember delta y? How do you write delta y? F of a plus h. Good. F of a. Worked on that, right? How about delta z? How much did the z value increase in the Cartesian coordinate plane as x increased by h, right? So h here is delta x, is g of a plus h, right? And g of a. And I call this one an analysis. This one allows us to write f of a plus h and broken into sum of two things, right? F of a plus is one term, now it's a sum of two things. What is it? F of a plus delta y. So it's broken into a sum of two things. That's the key idea of this whole technique of proving product rule, and quotient rule, chain rule. This is the key idea. This is the most important part. So how about g of a plus h? How do we analyze this one? It's g of a, and there's an increment by delta z. So we rewrite it like this. The key difference it makes. And I like this proof better than usual textbook proof because you don't have to factor and group anything. It's so natural how it folds out and cancels. All right, then we define W, right? Oh, let's emphasize this. Delta y divided by delta x. What do we know about that guy? That's called slope of what line? Secant line. But what we want is a tangent line, right? So limit delta x approaches 0, which is also denoted by h. Make sense? So what is that? F prime of a, exactly. That's the convenient notation, f prime of a. But delta y and delta x shows up. So limit delta x approaches 0. Delta z divided by delta x is known as g prime of a, slope of a tangent line at a. Make sense? All right. So these were set up. Then we enter w. Remember that? W. So now here, let w be, what kind of function was that? Our target function, our goal. What is the goal here? What is it we're trying to prove here? It's in the box. It's about what function? Product of two functions, f of x and g of x. So w is f of x times g of x, the quantity that changes. But we are interested at a. So let's write this one down. This was a part that you have to be careful. Delta w, I was saying it looks just like this, right? And in this part, exact that x, the function part, with all the x's appearing is replaced by something, and all the x's appearing is replaced by something, right? What is the first slot? All the x's are replaced by a plus h, remember? A plus h. So this is a plus h slot. So f of x is there, right? So that is changed by a plus h, remember that? And there's another x that is also switched by a plus h. That's the meaning of plugging in a plus h to this function. All the x's changed to a plus h. This is a slot for x equals what? A. And this is a slot for x equals a plus h. Does that make sense? That's the delta value always. So what is it? F of a times g of a. Is that right? Okay. So this is a key part. You write this delta w correctly. Now, what can we do about this f of a plus h and g of a plus h? We analyzed it, right? We analyzed it right up there. This is the, how do we break that f of a plus h? And this is how it breaks with this further notation. Make sense? So we substitute giant thing. So what is that? F of a plus h? F of a plus delta y. Good. How about this one? G of a plus delta z minus simple f of a times g of a. Make sense? That's what the increment of delta around a. Yeah, we can expand it, right? This is one term and there's no f applied to this. It's broken apart. That's the key property there, analysis. So let's expand it. So that's the first term. How many terms do you expect if you multiply two terms with the two terms in there? Two factors to four terms exactly. So let's yell it out. What term do you see? F of a and g of a, right? F of a and g of a. And you multiply that, f of a delta z. That's right. So let's do the second guy. So we multiply delta y to ga. Is that right? Plus delta y to ga. How about the last guy? And then delta y to delta z, right? Delta y to delta z. Is that right? Yeah, you see cancellation, something cancels out. F of a, g of a, f of a, g of a, right? So that part cancels out. So we have f of a delta z plus delta y, g of a, delta y times delta z. All right, so worked it out. That's what the delta w is. Make sense? So we want to calculate delta w divided by delta x. That will be the secant line. Of what function again? The product function right there. Okay, so we're going to put delta x underneath it here. That's all we have to do, right? You know it distributes, right? So let's see what happened. If you put, where would you put this delta x? You don't put the delta x here and there, right? It goes only to one factor, you know that. And if it's addition, it gets delta x goes there, delta x goes there, and delta x goes there. But individual factor, you only put delta x one place. F of a, there's no change. Do you see that f of a is not changing at all? So you will leave it there. And let's put that delta x underneath delta z. Why is that a good idea? Because we know nice behavior about that guy, right? Delta z divided by delta x. Show you. Right, delta z divided by delta x. What's the behavior? It exists and it goes to a number known as g prime of a, right? All right, so that's, you just try to put delta and delta stack up. That's a good idea. Maybe that's a short answer to that. So what would you do to the second term? Yeah, put it underneath the delta y. Maybe the good thing will happen to that guy. That's right. And then you multiply by g of a. Now you have two choices, right? Where would you put a delta x underneath it? Turns out it doesn't matter. All right? So I'm going to put it first choice. And leave that outside delta z there. Is that all right? Now we organize it very nicely. Then all you have to do is now hitting with not equal symbol. What is the good symbol that connects to next one? Arrow, right? As what approaches what? Delta x approaches 0 or h approaches 0, doesn't matter. This is what we want. With, delta w divided by delta x. What happened to that one? That's what we're analyzing. So let's see. F of a is this. Where is this one going? F of a. It's not changing at all, right? F of a is just f of a. It's a constant, a relative constant. F of a. So delta z divided by delta x. What do we know about delta z? Here, if you go to delta z divided by delta x is approaching g prime of a. That's what this means. Not exactly g prime. This notation means that it's approaching, but they still use this equal symbol. So that's going to be g prime of a. Is that right? And plus, what about this guy? Delta y divided by delta x. We know its behavior is f prime of a, right? So it's f prime of a gets there, multiplied by g prime of a. Now, what about delta y delta x? That's f prime of a, right? How about delta zx? Delta z? Right. Forgot to mention that if g is continuous, would you agree that this input value is getting closer and closer, so this whole thing is approaching 0? Would you believe that? Although we didn't discuss about that. Right. So input value is a plus h. So as h approaches 0, this a plus h approaches a, so this one and that one must be very close. That's the continuity, right? So assuming the continuity. All right. So that's approaching 0. Assuming the g is continuous at where? At a, which is actually implied by the differentiability that I postponed it because I wanted to cover these product rules first. So there's a little gap, but if we're going to assume the differentiability we have it in there kind of actually implies a continuity, and so that's why we have it, because I'm going to state it there. That kind of logic. If it is like that, why didn't you apply the other, the thing? But delta x is down there, right? As making it in indeterminate form. That's why I grouped it this way. The grouping makes a difference in your logic, right? Very good. Assuming g is continuous at 0, and which is implied by what condition we imposed already? Differentiability. Yeah. We assume differentiability, right? Turns out the differentiability is stronger than continuity. So if you have a differentiable, it's automatically continuous, which I didn't discuss it here. So if you use that, this factor approaches 0, and that factor approaches f prime of a number, right? So we have to go all the way back to conclude the last term. What kind of thing do we use? Delta z approaches 0, which is what this discussion's about. Limit laws, right? This one approaches some number. We don't know, but it approaches something. Then product of two things approaches a product of that convergent number, right? That's exactly the limit law. So we're using the limit laws here. All right? So, but we don't state the limit laws anymore. Just leave it like that. Hope you understand this one. So let's simplify this one. That's flat out 0, right? So that's exactly. Let's reorganize it, because that's how the answer, our product will organize it. A plus b is equal to b plus a, right? You know that. So it's a b f prime of a, switch it around, plus f of a times g prime of a. Right. So what's the next step? I think this is it. Don't you think we proved it? Right? What did you say? Sorry about that. Oh yeah, that was reasoning. That would be wonderful. But I think we show that this one approaches that number. Good. All right. So let's go back to differentiation rule. So we calculate the derivative. No, slope of the tangent line of that product function at a. We show that that's exactly that, right? With very little information of that, we were able to organize this. Good.